Hello, everybody! Welcome to another live stream. Thank you all for coming today. It's your host with the most, Joe himself. How's everybody doing today out there in the world of Twitch, the world of YouTube, and the world of Facebook? How we doing? I want to thank everybody out there for watching my videos. I hope you guys have been enjoying them. This has been an excellent experience, all right? We're going to continue on where we kind of left off. Well, not kind of where we left off. Where we left off last Friday, okay? Last Friday, we ended up on chapter 3. Get my book. There we go. All right. So, last week, we ended up on chapter 3. All right. The fundamentals of WAN and IP routing, okay? So, what I kind of said last week is I don't want us to regress in our knowledge here. So, what we're gonna do is first thing first, okay? We're gonna jump into the Pearson test program, okay? We're gonna review chapter 1, chapter 2, and chapter 3 all together in one whole test, okay? We're going to see how well we did. I think I'm pretty confident we're going to be all right. We might get a couple of, we might get hung up on a couple things, but that just goes to show that we still need to continue studying. But then from there, chapter 4, this should be a good chapter and a good introduction into for a lot of those out there who really haven't had much experience on the command line interface, okay? Because chapter 4 is part 2, all right? It's implementing Ethernet LANs, and chapter 4, all right, is using the command line interface, okay? So I'll just go over it. So part 2 of the CCNA 200-01 book. Part 2 is Chapter 4, using the command line interface. Chapter 5, analyzing Ethernet LAN switching. Chapter 6, configuring basic switch management. And Chapter 7, configuring and verifying switch interface. Okay? So, Part 2, what we're diving into this week, okay? Because this will take us all the way up to Thursday. All right? Now, depending on where our knowledge is with everything, Friday we might do a complete part 1 and part 2 review. All right. We also, again, depending where we're at, we might do some labbing on Friday and whatnot, or we'll just jump into chapter 8. Kind of, I don't want to jump into a whole new part. And then leave off the weekend without continuing to dive into that. So again, depending on where we're at Friday, we're still gonna be here. We're definitely gonna be putting on our knowledge caps. All right, like I tell everybody, bring your coffee, put on your knowledge cap. Let's do some learning. But let's have some fun doing it at the same time. Okay, everybody. So yeah. What happened today? Today was a good day. Today, I got to mention you guys. What was it? Over the weekend, I had brought it up a couple times. And if you caught my stream on Sunday, which was last night, I was building a Ansible lab in CML 2.1, from soup all the way to getting a playbook to run. I built a brand new Ansible lab off of CML, and what I'll do is I'll just show you that real quick. And but what it was, today, tomorrow, Wednesday, and Thursday. I'm in a class with Xander von Wundt. Xander von Wundt, he's an author. He's wrote about 60 books, primarily around Linux and Red Hat Enterprise Linux. All right, he's got a new book that hasn't dropped on hardcover yet, because I guess recently they've been having issues with getting printed books out. but digitally, he just dropped a new Ansible book that I'm gonna hopefully be picking up here as soon as it gets on. I again, guys, yes, I have everything digitally, but I still prefer to have the hard copy book of it, just because it's this important fact right here, guys. I with all my books, I do it all with every single one of them. For me, it's been a good practice of mine, as you could tell. It's like reading rainbows. All right, what I do is I thumbnail and I tab everything out. That way I can just jump right back into it. And if there's a particular topic, a particular configuration setup or something like that 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 I'm just interested in, that I find some value in, boom, it gets a tab. All right, and I feel as though it has helped me being able to maintain this knowledge and being able to just go back to it and not get frustrated with it, because I know for sure I have somewhere I can go and find this within a blink of a second. Okay, having things, again, some people prefer to do it electronically. I still prefer to do it the old school way. I just feel like there's something behind having an actual physical book in my hand. I still love it, but I also believe that there's a lot of power behind the digital platform too, and that's why we're utilizing it on as we're going through this streaming study here. And I hope you guys are finding something out of it. I hope you guys are gaining. What do we got? No, I don't want to buy no followers. Stop you. The last 3 times you've done this to me. It didn't stay up on my thing. Hold on 1 second. I just want to make sure this doesn't. All right, good. I hope it is. I just wanted to make sure that chat thing didn't stay up on my screen. But to get back to what I was saying, I hope you guys are really gaining something out of this. I am. I've actually been able to increase my knowledge about these topics, and been labbing them up and enjoying labbing them up. So without getting to too much everything, do you guys want to see let's jump right into Pearson. Let's jump into Pearson. Let's do our chapter review. Let's get this show started here. I hope you all are doing good out there. I'm having the time of my life tonight. Just got dinner done for the kiddos. Their bellies are full. They're Fortniting it up right now, having the time of their lives. It was my boy's birthday the other day, and we had a couple of extra things of cake mix hanging around, so they got another cake for them today. So they're probably what's the saying? While their parents are away, the cats will play. So I bet they're all scarfing down more cake than I want them to eat tonight. But whatever, they're having fun. They're being good. My kids are good kids. All right. How many questions do we want to do? We're gonna go with the full gambit. How many questions do you think we're gonna get out of this? Huh? I guess we'll find out. We're gonna find out together. All right. So we got chapter. Yeah. So like I said, we're gonna review last week, which again was chapter 1, chapter 2, chapter 3, and chapter 4. Chapter 1 is Introduction to TCP Networking. Chapter 2 was Fundamental of Ethernet LANs. Chapter 3 was Fundamental of WANs and IP Routing. And then Chapter 4 was what? Look at that. I'm glad I go back and check things out. Today is using the command line interface. We haven't got that Chapter 4 yet. Alright, so Chapter 3, Fundamentals of IP WAN. So let's do it, guys. Let's do it. All right. The term segment refers to which layer PDU. All right. Segment. Now, we got to think. We went over this. All right. So when we think segment, we got to think transportation. This goes back to the 5-layer TCP model. All right. All right. 1, 2, 3, 4, 5. You got, all right, layer 1, which is the physical. All right. Layer 2, which is the data. Yeah. The data, which is, you got to think when you, all right, so layer 1, that's physical, that's the wire, that's the Ethernet cable. All right, layer 2, you got to think MAC address. All right, that's, so layer 2, layer 3, that's the network. All right, think IP addresses. All right, layer 4. All right, this is that's the TCP and UDP. All right, that's the transportation. All right, and then layer 5. All right, layer 5. Don't fail me now, Joe. You gotta remember what layer 5 is. All right, yeah. So that's the app. This is where you get HTTP, SSH, all right, the session. All right. So what we're going to be doing, so the segment, that refers to the transportation, okay? So what PDU, we're going to go with segment, all right? Transportation, there we go. Let's go to next. All right. A user has sent a request to a server. What process does the server go through to determine which service is being requested? So a user has sent a request to a server. What process does a server go through to determine what service is being requested by the user? All right. So we got segmentation, fragmentation, de-encapsulation, encapsulation, okay? So if the user on the left is asking the server, what do you want? So what do we want? Determine what service is being requested by the user. This has got me stumped, but I'm going to go ahead and segmentation, that's transport. Fragmentation. Let's go with fragmentation. Oh, was I right with segmentation? All right, let's read it. As data is sent from the sender to the receiver, the sender encapsulates the data into a segment. I was right. It's the transport. See that what happens when you second guess yourself? Which are encapsulated into packets, then into frames, then sent in on the wire's bits. Okay, the receiver de-encapsulates the PDU in the reverse order to determine what actual data that is being transmitted. Segmentation, layer 4. Again, segmentation, which is the transportation layer. All right, is used to chop up large data blocks into smaller parts of transmission. Fragmentation, there we go. Fragmentation, I haven't heard that as being so. Fragmentation on layer 3 is used to take a packet that may otherwise be too large to be supported on a given network and chop up the packet into smaller packets for transmission. All right, so we just actually learned that. So fragmentation, I'm going to write that down. You know what's funny? I'd never heard that before, but that's what we're doing these reviews for. There we go. We'll go next. All right. IP functions at which level of the OSI model? Okay, so again, IP, network. All right, so that's going to be the network model. All right. Which of the following terms represent a layer 3 PDU in the OSI model, which includes the network layer, header, and encapsulated data? All right. We're going to go with packet, IP packet. Okay. All right. The output comes from a network analyze tool. It lists a group of lines, each header in the PDU with the frame data link header on top, then the next layer, typically the IP header, and so on. The first line in each section has a gray highlight, which with the indented lines below each heading line lists details about the fields inside of the respective header. You will need to remember some part of the various headers and compose those concepts to this output. The answer to this question. Okay, so in describing line A from the graphic with an OSI model perspective, which is the correct label to be used in combination with that PDU? Okay, so where to go? Typically IP header. So what do we got? The output comes from a network analysis. It lists a group of lines from each header in the PDU. The frame data link header on the top. Okay, layer 2. Then the next header, typically the IP. The first line in each one is grayed out, which in indented list details about fields in respective header. You will need to remember some part of the in describing line A from the graphic and the OSI, which is the correct label PDU? Oh, okay. So it is a data gray, yeah. Because you got packet, segment, packet segment. Okay, don't get confused. It's a frame, right? All right, here we go. Here's another one. Based on the packet capture shown, which is true? Let's look. Line A is used for logical addressing routing path. No. Line C is used information about the no. Line C corresponds to the transport. Yeah, I would say that. Line D is used for communication established in flow segment. Line B ready to transmission. So it's gonna be line C corresponds to the transportation layer. Okay. All right. So here we go. The network in the figure uses Cat5 cabling with the RJ45 connectors. Which of the following statements are true about the wires inside the cabling and the RJ45 pins on which one they're connected? Okay. All right. So we got to select 3. We got to remember select 3. So cabling on PC1 and switch 1. So remember, this goes back to switch logic and PC logic. Remember, PC logic is the same as router, and then switch is the same as hub. Okay. So we're gonna say, because remember they're opposite. So since they're opposite, they're transmitting and receiving on that same pin. Okay. Nope. That one. And then we're gonna go with this one. Okay. All right. The network in the figure uses Cat5 cabling. Let me just jot that down for you guys as we're reviewing. Let me do that too as well. So you guys, where did my eraser go? Eraser, where did you go? There you go. You're hiding. So PC and router. Router. All right, PC, switch, and then hub. Okay. Not hub. All right. So if you line up the pins, so there's 1, there's 2, there's 3, there's 4, there's 5, there's 6. So this would be straight through. All right. Because on pin 1 on the PC, this is like say it's receiving. On pin 1 on the switch, this would be transmission. Okay, same thing. 2, that'd be obviously receiving, and that'd be pin 2 over here would be transmitting. All right, but if you were to take the switch in the hub, all right, on pin 1, it's receiving on say pin it goes pin 1 to pin 3, and then pin 2 to pin 2 to pin pin 6 or something like that, but it's crossover. So straight through and then crossover. Okay. All right, straight through, crossover. All right. All right. So the cable from switch. Nope. And then sure. And then we got to answer 2. We got to get 2 of them. Okay. Nope. Not on that one. None on that one. Nope. And yes. No. 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 Is it pin 2 to pin 3? Question. Oh, all right. From the output of R1, which of the following is accurate? Okay. The hardware field represents that's the MAC address. Okay. R1 will use the address as a layer 3 address. Nope. R1 has learned the IP address in less than 1 minute. Nope. The address of assigned to assume that never to be duplicated again. So remember, the MAC address, which this is representing right here, is a it's a universally unique identifying number assigned to a NIC card. All right, that's the network interface card. So the MAC address is a uniquely assigned number to the network interface card. Okay, so just as this states. Okay, let's move on. 10 out of 24. Ooh, got 14 more to go. All right. Refer to the diagram. The new connection that has been going between Campus 1 and Campus 2 routers is required to provide at least 500 megabytes per second of bandwidth. The routers are located 3,000 meters away from each other. Which standard of Ethernet should be used in this situation? All right. So we have to go, not only are we looking for fast speeds, we need to go the distance too, okay? Now, these numbers, trust me, this is a tough one to remember. Just because these are awkward numbers to remember, all right? But we're going to think Z. We're going to think Z because Z, am I right? Yeah. Z is gigabit Ethernet, okay? So let's just always remember, when we see Z, Z is telling us gigabit Ethernet, okay? Let's go with Z. All right, here we go. So what kind of fiber is the picture referring to? Now remember when we were talking about fiber optics, cabling and whatnot. So when the core, all right, when the core has a greater span, all right, it's going to be referring to multi-mode because it's hitting in multiple areas. It's just not going straight through, okay? So this is obviously multiple. All right. This above comes from a network analyzing tool. Yep. Okay. The circle field part of the Ethernet header lists a value of hex 0800, which in this case means that an IP header follows next, as shown in the next line below the circle field. What is the name of the circle field? That is the type. Another top one, all right. Which fields are in the IP? Oh, this one we got wrong last time. I remember this one. So I didn't, because I skipped over this. So, and this again, this is from what I gather. Read the whole entire question. Okay, so we have to select 3 answers. Okay, so we got time to live, we got DS, all right, and then we got protocol. All right. In the figure, Cat5 cabling, which of the following statements are true about the wires inside the RJ45 pins? Okay. So doesn't say we have to multi-select, so we don't have to worry about multi-select. So we just have to get the correct one. So the cables from PC1 connect to, nope, because that's straight through, man. The cables on PC1 to switch 1 is connecting to switch. I'm gonna say that's right, but let's just read the other ones. Nope. And nope. Okay. Let's move on. The diagram shows a simple internet network which all LANs connections use fast Ethernet. Select the answers that list the correct cable types. Select 2 answers. Okay. So the Ethernet crossover cable between S1 and router 1. Nope. An Ethernet crossover cable between S1 and hub 1. Nope. A rollover cable, a crossover cable. So we have, what do we got here? This is a good one. This is a good one, folks. All right. We got a crossover cable on that one. All right. And we have a crossover cable on that one. Because remember, switch and hubs are the same. So they use crossover cables. Okay? A device uses MAC address 00 yada yada yada. Which part of the MAC address indicates the originating network equipment vendor? All right? Now, it's the first half. Okay? It's the first half of that MAC address. All right. A user at host 10.3.0.1 powers on the device and issues a ping to 10.3.0.2 command, which is true about the ARP, address resolution protocol, request sent by host 10.0.3.1. All right. This is part of the DNS process. No, host is attempting to learn the layer 2 address. Ooh, I like that one. The frame will be all right. The device processing the request will reply with the unicast address from host. All right. Let's go with that one, and let's go with that one. All right. All right. Based on the diagram, host A sends a packet to server B. The two serial links in the HDLC, that was high level data. Oh man, this is such a tough term to remember. High level data. Logic controller? I think so. Yeah. While the rest are Ethernet. How many times does the packet experience re-encapsulation by the router? Okay, now remember, all right, when the packet is going through these routers, all right, it is stripping away that MAC address, okay, and it's keeping the IP address as the source. So the destination, the source IP will remain in that packet, but that source MAC keeps getting ripped off, okay? So it's de-encapsulating that packet as it's going through, okay? So if host A sends a packet to server B, it's going through one hop. So 1, 2, 3, 4, 5. Okay, so it's being de-encapsulated 5 times. All right. All right. In the figure, all devices are statically configured with the IP address with the IP address, mask, and default gateway information. Assuming that all switches and PCs have just completed a reload, the switch MAC address tables are tables are empty. The PC ARP tables are empty, and none of the PCs or routers have sent a frame. Which of the following two? So, what it's pretty much stating is all these devices, none of their tables have been their tables haven't been filled up. Nobody knows where anybody is yet. Okay, so you gotta understand when traffic starts flowing through this wire, the switches are building their MAC tables, the routers are filling up their ARP and stuff like that. Information is being collected. Okay, all right. So we need to select 2 of the right answers. Okay, let's do this now. Let's work through this. It's a little bit complicated one, but we'll get through it. All right. When PC1 pings PC2, let me get my handy dandy marker over. I love this thing. All right. All right. When PC1 pings PC2, the first Ethernet frame will have R1s. The first Ethernet frame will have R1's fast Ethernet 0-0 MAC address as the destination address. Let's look at that. So if I sent a message, a ping, it's gonna go pew, and then pew, and then no, because it's gonna be flooded. All right, let's move on. Let's read some of the other ones real quick. When PC1 pings PC2, its first Ethernet frame will be an ARP request. No. When PC1 pings PC2, the first Ethernet frame. No. All right. Well, we're almost we're narrowing this down. When PC1 pings PC2, its first Ethernet frame will have PC2's MAC address as the destination address. Yeah, that one's right. Okay. When PC1 pings PC2, the first packet will be, it's going to be an ICMP echo request. Of course it is. What else would it be? What else would it be, I ask? All right. Whoa, I got them both wrong. Let me read this. PC1 does not have ARP table. Ah. Okay. It got me. Man, these things get tricky sometimes. Alright. So PC1 does not have an ARP table entry for PC2 yet. Because it has been loaded and has yet to attempt to communicate to PC2. Therefore, the first frame will contain an ARP request with the LAN broadcast of MAC address FFFFFFFFFF. Okay. So here we go. So again, guys, I'm always learning. When PC1 pings PC2, the first one would be an ARP request, and then that ARP request which lands on the LAN of the broadcast address. Okay, cool. I accept it. Which answer lists the Ethernet base WAN service? So Ethernet wide area network service. All right. So which so we got Ethernet over MPLS and then lease lines. Oh. All right. Let's read it. Ethernet service includes Ethernet lines, E-lines, and Ethernet LANs. Serve EMPLS. So we got that one right. Man, I got stumped on these lines. I can't believe that. All right. How does the receiver of the HDLC frame know what has been encapsulated within the frame? All right. It doesn't give us, we don't have to, it's not multiple choice. I know it's the type header, but let me just make sure. We got the last two wrong, Joe. Let's make sure we're reading these. All right. The type field in the header, pretty sure. I know it's not that based on the FCC field. No, and no. So it's a type. Know that one. Which of the following data link layer protocols are used to encapsulate data on a leased line? Which of the following data link protocols are used to encapsulate data on a leased line? So we have PPP and HDLC. A leased line provides a layer 2. Oh, layer 1, Joe. Come on. It's a line. It's a hard line. That's what it is. You guy. Man, I am slowly thinking I got to review chapter 3 on my own. All right, which protocol finds an unknown layer 2 address from a known IP address? Which protocol finds an unknown layer 2 address from a known IP address? So that is ARP. Grade me. How did I do? I hope I did good. I hope I passed. Let's see our results. Woo, woo, I passed. Man. All right, let's look at our scores now. So, chapter 1, yeah, we got one wrong. I know chapter 2 pretty well. And chapter 3. Boy, I have guts to review chapter 3. Fundamentals of WAN and IP routing. Yeah, I've got to do some chapter 3 reviewing. All right. That was a good one. So, I mean, this is why we're doing it, to ensure that, you know what, we might just do, let's do this again. Let's start a new exam real quick. I'm going to review chapter 3 one more time. We're just going to do chapter 3, guys. All right. Which answer list Ethernet-based WAN services? So we have MPLS. And what do we have? We have Ethernet line service, E-line. Let's drill that into our heads. I'm going to drill this into my head right now. Right now. So, which answers are Ethernet? List Ethernet-based WAN services. All right, we have MPLS, EOMPLS, and then Ethernet line service. All right, short for E-line. All right, Ethernet-based WAN. So Ethernet-based WAN services. WAN again, wide area network. All right, Ethernet-based WAN services, that is represented by EMPLS, all right, and then Ethernet line service, E-line. All right. Next one now. Promise you this ain't gonna take me too long, but I'm gonna drill this into my head, so I'm got this for good. Which of the following data link protocols are used to encapsulate data on a leased line? All right, we have PPP and we have HDLC. All right. A user at host 10.da pings this one. Ooh, yeah, I got this one wrong, didn't I? So a user at host 10.3.0.1 powers on a device and issues a ping to 10.3.0.2 command. What is true about the ARP request sent by 10.3.0.1? All right. All right, yeah. We knew those two. So the device is processing the request will reply with the unicast address. All right, from 10.3.0.2 to 10.3.0.1. The host is attempting to learn layer 2 addressing. Okay. At least this one got me. A lease line, so physical. We gotta think physical. Joe, physical. All right. So remember when we read about this. All right. Here's a building. Here's another building. All right. This is Chicago. Welcome to Chicago. Have a deep dish pizza in Chicago. Okay. Hey, get me a pizza, huh, Johnny? All right. Here's our building. All right. These are old school buildings, and these telecom companies. All right. In the olden days, they built in under these buildings in their little offices here. They put in hard lines, okay? Because they were smart about things, and they knew that someday these lines were going to be used for companies and people living in these buildings, and you know, they were able to branch that off. So a lease line is a layer one. Okay, I'm drilling this into me. This is for my own good, guys. A lease line is a layer 1. All right, service, because it's an actual physical line. Physical. All right, physical line. All right. All right. Based on the diagram, host A. Yes. So, host A sends a packet to server B. The two serial links use the HDLC header. While the rest are Ethernet. How many times does the packet experience re-encapsulations? Now remember, I know I got this. I know this one, but I'm going to drill this into me. All right. Doing some drilling, guys. Doing some drilling. All right. So here's our PC, router, and then server. Okay, server, and then here's our little PC, server. Okay. So again, when PC1 sends that packet, choo choo. All right, it's gonna be in here. It's gonna be encapsulated. It's gonna get sent over to this router. It's gonna be de-encapsulated again, sent over here, de-encapsulated, and then finally sent over here. So it's gonna make a total of 5. All right, 5 de-encapsulations. I'm not even gonna try to write that word. All right? Because remember, when that packet gets sent to that router, all right, it's gonna keep PC1's IP address, all right, inside of that packet, all right. But that MAC address, all right, is gonna get changed now to source MAC address R1. It's going to come over here. It's going to have PC1's as the source IP address still, but then it's going to pick up. All right, it's not going to pick up. It's going to take off R1's MAC address as the source, and then it's going to say on now the source MAC address is now me R2, but the source is that. Same thing with here. It's going to say now the source is my MAC address at router 3. Now it's going to say the source MAC address is router 4. Source MAC address is router 5. So when that packet gets to server, all right, it's going to have the IP address as the source of PC1, all right, but it's going to have the MAC address, source address, as router 5 over here, okay? All right. All right. Next. All right. Which protocol finds an unknown layer 2 address from a known IP address? Okay. So again, layer 2. All right, layer 2 is the that's the MAC address layer. All right, that's where you find the MAC address. That's the data. All right, that's where it's sending the frames and whatnot. All right, so what is that message that who is at 10.0.0.1 and can you tell 10.0.0.2? That would be ARP, address resolution protocol. Address resolution protocol. Those are those messages that you see flying through. Once you hook up those lines, those are those messages you start seeing through. Okay, so let's go with ARP. All right. How does the receiver of a HDLC frame know what has been encapsulated within a frame? All right. How does the receiving HDLC frame know what has been encapsulated within the frame? All right. That is the type field header. All right. Type field header. All right. This is the one that tripped me up last time because I was not paying attention. I just wasn't thinking. I wasn't really forethoughting about how everything. So again, we have to put into our mindset. Everything is turned off. Everything is completely turned off. Nothing has been done with this entire network at all. Okay? So again, we have to take the step back and think about what the question is truly asking us before we go ahead and start answering it. Okay? So in the figure, all devices are statically configured with the IP addresses, mask, and default gateway information. Assuming that all switches and PCs have just completed reloading, the switch MAC addresses tables are empty, the PC ARP tables are empty, and none of the PCs or the routers have sent frames yet. Which of the following are true? Okay. Let's think. Let's take everything back and think in complete bone dry, nothing has been done yet network, and then all of a sudden we turn the key. We turn that key and already we're getting messages. Even before that ping goes out, we're already starting to get DHCP messages. We're getting ARP messages. We're getting all these messages starting to fly through the wire. All right? So let's think about that. All right? When PC1 pings PC2, the first frame has the broadcast address, the broadcast destination address. No. All right. When PC1 pings PC2, the first packet will be. That's what I know. I know you guys seen that. Which is the one I picked before, because I was thinking, yeah, sure, it's an ICMP message. I wasn't thinking that couple steps back, okay? So when PC1 pings PC2, the first Ethernet frames has, it's not that, okay? It doesn't care about that router. That router is over here. But what's going to happen, though, is that it's actually going to be flooded out everywhere, all right? Because again, nothing has been done yet. So, in all rights, everything is going to be flooded out everywhere to every single thing, because the whole network is trying to figure out, where's Tom and where's Sally at. All right. So, again, I got to think about how I'm answering these questions. Okay. When PC1 pings PC2, the first frame will have PC2's MAC address as the destination address. All right, let's go on. When PC1 pings PC2, the first Ethernet frame will be an ARP request. So, who is at 10.0 whatever, send that back to 10.0 whatever. So, the first frame is going to be an ARP request, okay? Because we're looking for layer 2 addressing. We want to know what's going on. We're trying to figure out where everything's at. All right. All right. In PC1, pings PC2, the first frame will have PC2's MAC address. Okay, no. All right. So, again, when I just draw all those lines, it's going to be a broadcast destination address, the FFFFFFFF. All right? That's what it's sending out. That's what ARP is sending out, the FFFFFFFF. It's sending that out to everybody. So, this ARP request is relating to the broadcast destination address. All right? That's the FFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFfffffffffffffffffffffff destination, broadcast address, okay? All right. All right. I had to drill that into my head, guys. I had to do that. Not only for you guys, but for me, myself, personally. All right. That way I can, you know, knock on wood, knock it into my rock hard head here. All right. Cool. I'm happy. That was a good review. That was an excellent review, actually. You know why it was excellent? Because I learned something. That's why it was excellent, guys.
Hey, guess what?
What's up?
I completed Five Nights at Freddy.
Did you really?
I kept all the doors closed.
All right. That's good.
Yeah. And I can make a
All right. Hey, come on.
I got like
Crazy monkeys.
$240.
My little monkeys are playing Five Nights at Freddy. That's awesome. They're gonna keep me up all night now with nightmares. That's great. All right. Let's keep it moving here. All right. Let's X that out. And let's X that out. Okay. Now, let's jump into part 2, implementing Ethernet LANs, okay? Part 2. Part 1 provided a broad look at the fundamentals of all parts of networking. Focus on Ethernet LANs, WANs, IP routing. Part 2 and Part 3 now drill into depth about the detail of Ethernet, which was introduced in Chapter 2, Fundamentals of LANs. Part 3 begins that journey by discussing the basic of building a small Ethernet LAN with Cisco Catalyst switches. The journey begins by showing how to access the user interface of a Cisco switch so that you can see evidence of what the switch is doing and configure that switch to act in the ways you want it to act. At this point, you should start using whatever lab practice options you choose in your study plan. Sections that precede Chapter 1 introduce introductions to TCP network, and if you have not finalized your plan on how to practice your hands-on skills, now is the time. So, guys, if you're following my stream, what I suggest is to, let me pull it up real quick for you guys. Here we go. No, not that page. Where's my netcad page? I know my netcad page is right. Oh, here it is, my netcad page. I knew it was there. Real quick, guys. All right. Yeah, I got a whole bunch to do. All right. So this is NetCAD, guys. All right. Now, let me see. So what I'll do, so right here, guys, this is the NetCAD page. And this, what it is what I'm suggesting you guys do at this point, guys, if you go over to netcad.com, all right? Let me put that up in the chat. So that's https:// netacad.com. Stop. I hate when this phone tries to tell me that I'm spelling things wrong. No, phone, stop auto-correcting my spelling. All right, I threw that up in the Chizat. All right, guys. What that is, guys, is netacad.com. That'll bring you right over to the Cisco Network Academy. And then from there, you can download a free copy of Cisco Packet Tracer, okay? I urge you, if you're interested in getting some hands-on, this is going to be the best way for you guys to get hands-on, get on that command line, and really start learning about Cisco command line, Cisco iOS, and whatnot. All right, you can do everything you can do everything in this book right from Cisco Packet Tracer, guys. You don't need to be using Cisco Modeling Lab like I'm using, or GNS3. You don't need any of that stuff, guys. Okay, Cisco Packet Tracer will get you that hands-on knowledge that you need to get you guys where you want to be if you're serious about getting into your CCNA studies, okay? So again, I suggest and I urge you to go over to netacad.com, download your free copy of Cisco Packet Tracer. It's free, totally free. All you need is an email address, okay? You just have to sign up. That's it. That's all Cisco wants you to do. They just want your email address, okay? All right? And honestly, they don't even really send. And I don't think I even get emails from them. All right, so they're not gonna bother you or anything like that. All right, but again, that's totally up to you. But I'm urging you again, if you're interested, if this is something that you guys really want to do, go download your free copy of Cisco Packet Tracer. Okay, don't take my word for it. Look at all the other successful networking people out there. I guarantee they started off with Cisco Packet Tracer, or they will suggest that you start off with Cisco Packet Tracer. Okay, all right. Let's continue on. All right. So after you complete chapter 4, you will see how to get into the command line interface, the CLI, on a switch. The next 3 chapters step through some important foundations on how to implement LAN foundations used by every company that builds LANs in Cisco gear. Chapter 5 takes a close look at Ethernet switching, that is the logic used behind the switch, and how to know what a particular switch is doing. Chapter 6 shows the ways to configure a switch from remote access via Telnet or SSH secure shell. All right, along with a variety of other useful commands that will help you when you work with any real lab gear. All right, simulators and any other practice tools. Okay, chapter 7, the final chapter in part 2, shows how to configure a variety and configure and verify the operations of a switch interface for several important features to include speed, duplex, and auto negotiation. All right, there's the breakdown of the chapters. Chapter 4, using the command line interface. Chapter 5, analyzing Ethernet LAN switching Chapter 6, configure basic switch management. Chapter 7, configure and verify switch interface. Okay, so let's dive into Chapter 4. All right, using the command line interface. My favorite thing, guys, is using the command line interface. All right, it's my most favorite thing to do, from Linux to Cisco, to anything else, to my toaster, to my coffee maker. Using the command line interface on all of them is my most favorite thing to do. Who needs a GUI, I say? Throw out your GUI. Use the command line interface. I'll tell you the truth though, there is the power in the text in the command line interface. That's where the real power is. You can do just dropping those words in there. You'd be surprised what you can do. All right. So this chapter covers the following. None. All right. Let's dive into it. This chapter explains foundational skills required before you learn about the roughly 15 exam topics that use the verb configure and verify. All right, let me say that again. Exam topics that use the verb configure and verify. All right, when you look at the Cisco blueprint for the CCNA 200-300 exam, you're going to see exam terminology that configure and verify. All right, what those mean is you have to have knowledge on how to actually configure and verify that particular topic. All right, and from what I hear from the exams, there are some possibly simulators or multiple choice questions that you might have to answer on what configuration, how you would set up a configuration on, a certain lab experiment. So, however, Cisco does not list the foundation skills described in this chapter as a separate exam. So there are no specific exam topics included in this chapter. To create an Ethernet LAN, network engineers start by planning. They consider the requirements, create a design, buy the switches, contract to install cables, and configure the switch to use the right features. The CCNA exam focuses on skills like understanding how LANs work, configuring different switch features, verifying that those features work correctly, and finding the root cause of the problem when a feature is not working correctly. The first skill you will learn before doing all the configurations and verification tasks is to learn how to access and use the interface of the switch, called the command line interface, the CLI. All right. This chapter begins the process of showing the basics of how to access the switch CLI, command line interface. The skills included how to access the CLI and how to issue verification commands to check on the status of a LAN. This chapter also includes the process of how to configure the switch and how to save that configuration. Okay, so that is a big thing. Save the configuration. Now, I'm going to show you. You're probably going to see me do the shortcut version of how to save it. But for the exam, you're going to want to know the long version, the correct version, okay? And that is, now the command line, this is where I kind of feel like some of my this is where like I spend most of my time, guys, is labbing. I spend so much time labbing. And I feel this is one of my strongest points, is actually utilizing the command line interface, okay? So let me get back to that. So to save, again, very important they save it, because these things just don't if you can do the most beautiful configuration in the whole world. I mean, it can be the configuration that has never been seen before by anybody and can work amazingly. If you don't save it, that's it. When you go to reboot that switch, Tom left Larry, and that's it. It's gone. So to save the configuration, the syntax, the full syntax, which you are going to need to know for the CCNA exam, is copy, okay, space, running, not warming, it's running, configuration, All right. Copy. Space. This copy. Now this is a space. This is an actual space. Running configuration. That's just one word. Okay. Running configuration. Start up. Start. And it's got a little dash right there. Configuration. Configuration. I'm running out of space. You get the idea. So that is the full syntax for saving your configuration. Okay. Now, again, I'm gonna try not to do my shortcut. I don't even know. Should I write down my shortcut? There's my shortcut, guys. That's my shortcut. That's the shortcut. WR. I love it. Saves me a heck of a lot of long time than to write out all that. But hey, let me erase that so you don't remember that. I don't want you guys to remember that. Don't remember that, guys. Where did my eraser go? Hurry up, before you guys remember that. I don't want you guys to remember that. All right, you guys didn't see that. All right. So remember, copy, running configuration, startup configuration. There you go. Now, don't look at over here. All right, I already erased it. Hopefully you guys didn't see it and remember it by that time. All right. Now, let's move on. All right. Note that this chapter focuses on the process that provide. Note that this chapter focuses on the process that provide a foundation for the most for every exam topic that includes the verb configure. There's that word again. Configure and verify. Configure and verify. There's that top. You know that it's that statement right there that you guys have to remember. Okay. Most of the rest of this chapter in part 2 and part 3 of this book then goes to include details of particular commands used. You can use to verify and configure different switch features. So it's going to start, obviously then there's more complicated configurations, more detailed configurations that later chapters are going to get into. And you have to, this is just going to start, this is just, just dipping your little toesies in the water of the command line interface. Okay. So let's try to do the do I know this already quiz. Let me do these real quickie. Again, I did these who knows how long ago, guys. Why do you hate me, I say? I say, sir. Sir. No. There it goes. I must have highlighted it probably 1,000 times or something like that before. That reason why it's got to do 1,000 highlights. There it goes. Woo. Scrolling too fast. Okay. In what mode can you type the command show MAC address table and expect to get a response with MAC address table entries? Choose 2 answers. Okay. All right. So let's come over here and we have user mode, we have enable mode, we have global configuration mode, and we have interface configuration mode. Okay. So we have to choose 2. All right. So we're going to do 1. What's up?
Can we have cake?
Can
Can we have cake?
you guys have cake?
Yeah.
What's all over your face?
Cheers.
Don't clean your face, dude. Yeah.
Yes, we can have cake, guys.
I'll be out there though to cut it for you guys in a minute, alright? But wash your face first, you crazy animal. Alright.
Guys, also, if you like Five Nights at Freddy's, download it. It's fun. I completed it, but I use all the unlocks. It will disconnect. No, you won't get any achievements. But it's fun. I didn't get jump scared.
You didn't get jump scares, you
No.
crazy guy.
I'm glad Anderson
Hey. Go clean up the living room. Hey. the living room first. All right, we're all cleaned up. All right, and then I'll be out there in a minute. All right. All right. Let's move on. Whoa. Whoa. Boom, 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 ba-dum, boom, 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 boom. There we go. No, one more. Ah. There we go. All right. Let's go down. In which of the following modes of the command line interface could you type the command reload and accept the switch to reboot? So, we are going to be in enable mode. Say B. Which of the following is the difference between Telnet SSH as supported by a Cisco switch? So, SSH encrypts the password used at login, but not other traffic. Telnet encrypts nothing at all, and I'm going to go into that as well. If you're using Telnet, you're asking for trouble. I could see your whole entire, if somebody's sniffing on your wire, and that's just simply using Wireshark, they can see everything. Everything you're typing into that switch, that router, whatever you're using, they can legitimately line by line see every single word you're typing. That's Telnet. So, don't use Telnet. All right. SSH encrypts all data exchange, including the login password. It's B. All right. Telnet is used from Microsoft operating systems. No. Microsoft uses SSH too. Telnet encrypts only passwords. No. The answer is B. So I'm going to say 3. I'm going to say B. All right. What type of switch memory is used to store the configuration used by the switch when it is used and working? All right. So this is gonna get the wheels are turning on this one. Which type of switch memory is used to store the configuration used by the switch when it is up and working? Okay. Now it doesn't get jammed into the ROM. I'm gonna say RAM. Ramrod. Say RAM. I'm gonna say 4. RAM or NV RAM. RAM or NV RAM. NV RAM is non-volatile RAM. RAM is RAM. And I'm tossed up between A and D all of a sudden. We're gonna go with A. All right. What command copy? Oh, here we go. What command copies the configuration from RAM into NV non-volatile RAM? Oh, I kind of answered that question right there. So, what did we say, guys? So, here it is. And damn it, I have it highlighted too. I don't want you highlighted still. Let me unhighlight that. All right. So, it's our little special one. Copy running, copy config, startup config. All right. So that is the Cisco answer right there. So I'm going to say 5 is F. All right. A switch user is currently in console line configuration mode. Which of the following would place the user in enable mode? Choose 2 answers. Okay. So we have exit. It's in console line configuration mode. Console line configuration mode. I know. I'm going to say B for one of them. Exit takes you just back a step. So if we're in the console line configuration mode, and we want to go all the way back to enable mode. I think that's 2 steps. That's 2 steps because console line configuration mode. So you would go from user enable global, then to console line configuration mode. So to get back to, it wants to go back to enable, so you would have to go past global configuration mode and then enable mode. Okay, so we're gonna say, let's say B and D. Pretty sure. See how we did, guys. All right. Oh, B and C. I got something wrong. Can I tell? All right. 1 is right. 2 is right. 3 is right. 4 is right. 5 is right. And then I got 1 wrong, so it's C. All right. I don't use Control C that much. Because I should start using it more often. All right. Oh my goodness, 1,000 notifications. Stop it. All right, so we got 1 wrong, and that was using Control Z. So Control Z. Let's hammer that down. So Control Z. Control Z will get you all the way back to enable mode. So what that question was asking is it wants to know, because when you're in console line configuration mode, so you already have, like I said, you're gonna log in to the switch. All right, you're gonna end up in user mode. From user mode, you're gonna go into enable mode. Okay, and that's where you're gonna do all your show commands, and you're gonna be able to look at everything, make sure everything's looking well. And then from enable mode, you go into console global configuration mode. All right, configure the terminal global configuration mode. All right. Now, when you're in global configuration mode, all right, that's another step. And then it's saying console line mode. So from global configuration mode, then you have to go into console line mode. Okay, so it's asking again, which of the would place you back in enable mode. So you have to go back 2 steps. So exit, I knew exit brings you back 1 step. So if we were in console line mode and I said exit, we would be back in global configuration mode. Okay, I knew that because I use exit nearly all the time. All right, and I knew end will bring you all the way back, blink, all the way back to enable mode, no matter what. Okay, I don't really use Control Z, and that's why I was kind of like, because I knew quit, quite over here, not even quit, it's quite. I know. Did I even? Oh, I did select. Man, I should have. That's quite. It's not even quit. Look at that. It was even trying to help me out. Man, I gotta use my noodle. I'm off my game today, I guess. I'm off my rocker. So, Control Z, Control Z. We'll bring it back. We'll live that up too, guys. Alright. Alright. Accessing the Cisco Catalyst Switch. CLI. So, forward. Alright. Accessing the Cisco Catalyst Switch. Alright. Cisco uses the concept of the command line interface CLI with its router product and most of its Catalyst LAN switch products. The CLI is a text-based interface in which users, typically a network engineer, enters the text commands and press enters. Boop. Pressing enter sends the command to the switch, which tells the device to do something. Yay! The switch does what the command says. It better. And then in some cases, the switch replies with some message stating that the results of the command. Cool. All right. Oh, too many. Cisco Catalyst switches also support other methods, both monitors and configures a switch. For example, a switch can provide a web interface so that the engineer can open up a web browser to connect to a web server running in the switch. The switches also can be controlled and operated by using network management software. This book discusses also Cisco Catalyst Enterprise class switches, and in particular how to use Cisco CLI to monitor and control these switches. The first major section of the chapter first examines these catalyst switches in more detail and then explains how a network engineer can get access to the CLI to issue commands. Okay, cool. All right. Cisco Catalyst switches. Within the Cisco Catalyst brand of LAN switches, Cisco's produce a wide variety of switch series or families. Each switch series includes several specific models of switches that have similar price, similar features and similar price variations, performances. So all of this is explaining is just the differences of like the different model switches and whatnot. So I mean, it's going from high cost to low cost switches. Just going to a little bit of depth of that. And then some of the ports, some of the port meetings and whatnot. All right. Cisco refers to a physical connector or either interface as a port. There you go, as a port with an interface type and an interface number. The interface type as the command as used in the command on the switch, either Ethernet, fast Ethernet, or gigabit Ethernet. And you'll see that, and so on for faster speeds. For Ethernet interfaces that support running at multiple speeds, the permanent name for that interface refers to the fastest supported speed. For example, 10, 100, 1000 interface. That is an interface that runs at 10 megabytes, yada, yada, yada. The uniquely numbered each interface. Some catalyst switches use 2-digit interface numbers, while others use 3. For instance, for 2, 10, da. So all this is pretty much stating, and you'll see this once we get into our lab example here. You'll have a switch. All right, so you'll have a switch. This is like I say, a physical switch, and on that physical switch, you can have upwards to whatever 40 or so. Most switches have a whole array of, depending on what switch model you get. What these are showing right here, these are the ports. Okay, that's where you're gonna be plugging your RJ45's connectors into it. You're also gonna have a console port. All right, and then on some of these newer switches, you have USB console ports as well now too. Okay, so what this is pretty much stating is you're gonna see terminology like gigabit, 0, 0-0, or fast Ethernet. So we'll do fast Ethernet, 1- whatever, or you'll have Ethernet. Yeah, what's the terminology for Ethernet? Is it ET? ET phone home? Is it ET phone home? Ethernet. Say 10. Dash. Whatever that numeric interface number is going to be. That's all. This portion is going into is just how each one of these interfaces has a unique identifying to the speed. All right, the speed of the port interface. All right, and then the identifying number of that interface itself. Okay, so that's all you're seeing right there. All right, guys. Woo! All right. Accessing the Cisco iOS CLI. All right. Like any other piece of computer hardware, Cisco needs some kind of operating system software. Cisco calls this OS the network operating system. Okay, so the iOS. So when you've heard me before say iOS, Cisco owned it first. Cisco iOS software from Catalyst switches implemented control logic and functions performed by Cisco switches. Besides controlling the Cisco performance and behavior, Cisco's iOS also defines an interface for humans called the CLI. The Cisco iOS CLI also allows the users to use a terminal emulator program like PuTTY. So if I was using, say, Rail Gear, I would hook up to the console port. All right, the console port on the switch. Okay, well, this is just switch. All right, this console port, even though it's an RJ45 type. Well, most of them they used to be a type RJ45 type port. It's an actual different cable. It's actually a console cable, and that's one thing to remember too, guys. You would hook up your console cable to, say, your laptop or your PC or whatever your management controller were, all right? And you would be using a terminal emulator, and the most popular terminal emulator is a program called PuTTY, P-U-T-T-Y, all right? P-U-T-T-Y, and that's an actual free software, guys, that you can download, and all you're doing is hooking, you'll be telling where, what you're telling, once you load up PuTTY, all you need to tell PuTTY, either you're connecting Telnet, you're connecting SSH. PuTTY has multiple options and has multiple different features now. These days, you can use PuTTY right away from SFTP to even more complicated ways of logging in securely into these devices. All right, remember, Telnet is unsecure. All right, SSH is secure. Okay, so that's what that is. Woo! All right. Yep, which accepts text entered by the user. When the user presses enter, the terminal emulator sends the text to the switch. The switch processes the text. If it as a command does what the command says and sends text back to the terminator. Okay. The switch CLI can be accessed through three popular methods: the console, Telnet, and secure shell. Okay. Two of these methods, Telnet and SSH, use the IP network, all right, in which the switch resides to reach the switch. The console in a physical port built specifically to allow access to the CLI. All right. Figure 2 depicts this option. All right. Console cable. All right. So there it is. It's stating console cable, serial USB. All right. To the serial port. To the it's going to be a RJ. Like I said, they have now these days. You'll see the USB console port now. Okay. All right. And it's you're hooking up through the console that way. All right. Telnet, here's Telnet and SSH. All right. So that's pretty much like say this say, all right, so that's representing, so you guys don't get confused by that. Say this switch is on your rack. All right, it's on a server rack. All right, server rack, and who knows, maybe this isn't, maybe you're not even in the same building as it. All right, and you're sitting in a different building, and you're the network admin here. All right. Again, what it's stating is, even though you're not physically actually connected to that switch right there through your PC, you're connecting through IP. All right, through Telnet or SSH. All right, which is secure shell. Okay, secure shell is the preferred method, and again, we're going to go into that. All right, but again, you're using the program PuTTY, all right, to again hook up through IP, all right, to that. Okay, or Windows, or on Linux, you can just do SSH into that device as long as you have that device's. Yeah, on Linux you can just type, telnet, IP address, and then it'll log you in. Same thing, SSH, IP address, and again you'll log in that way too. Okay, or you can use PuTTY too the same way, to that same type of thing as well too at the same time. So, console access requires both physical connections between the PC and the other device. The switch console port, as well as some software on the PC, Telnet SSH, requires software on the user's device, but they rely on existing TCP networks again. So what we just kind of depicted here to transmit the data. The next few pages detail how to connect to the console and set up the software for each method to access the CLI. So cable and connection, cable to the console connection. The physical console connection, both old and new, uses three main components: the physical console port on the switch, a physical serial port on the PC, and a cable that works with the console and serial ports. However, the physical cable and details have changed slowly over time, mainly because of the advances and changes with serial interfaces on PC hardware. Okay. For the next topic, the text looks at three cases, newer connections on both the PCs and the switches, older connections on both, and third case with the newer USB. So that I can't, it's funny that saying newer USB connector on the PC, but the older connector on the switch. Okay. So here's just a depiction of our RJ45 console. Hooking up to the console port on the switch over a rollover cable to the serial port on your PC or laptop. Okay, here is the RJ45 again, going into the console port with a rollover cable to a USB converter. Okay, USB to your PC. All right, now here's the obviously the more newer, with the technology just relying strictly on USB now, which again is the most efficient and better way to do it. USB port on the switch and USB obviously port on the PC. Okay. All right. And it's just talking about there. Note when using the USB method, you typically also need to install a software driver so that your PC OS knows that the device on the other end of the USB connection is a console of a Cisco device. Also, you can easily find photos of these cables and components online with searches like Cisco console cable and Cisco USB console cable and console cable converter. Cool. So here's a for instance of the USB console. It's a mini USB, all right, and here is the actual console port. Here is the RJ45. So on some of these switches, they still support both RJ45 console and USB Mini B console. Okay, all right. So there's still support for both on some of these switches. Okay, all right. I'm almost come back to me. All right. I'll keep going. Alrighty then. So here's a couple. Here's some key topics. So when you're using, again, we're going to go back when you're hooking up through the console, and you're using PuTTY or whatever, most likely it's probably going to be PuTTY. All right, and if you think that's funny, I think it's funny too. PuTTY, 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 PuTTY. It's going to be asking you, all right, these couple of questions. All right. And let me just scroll down a little bit to give you a little bit of context-sensitive help. All right. So bit rate, BU, baud rate, whatever. So rate, all right, it's going to be 9600. All right. Data rate, data bits. All right, it's going to be 8. All right. Partition, none. All right. And then stop bits. All right, it's going to be 1. All right. So 9600, 8, none, and 1. 9600, 8, none, and 1. 9600, 8, none, and 1. Cool. Drilled into my head. All right, let's move it. Let's keep it moving. All right. Here we go. Accessing the command line interface with Telnet SSH. All right, for many years, terminal emulator applications have supported far more than the ability to communicate over a serial port to local devices like switches, consoles. Terminal emulator support a variety of TCP/IP applications as well, including Telnet and SSH. Telnet and SSH both allow the user to connect to another device command line interface, but instead of connecting through the console cable to the console port, the traffic flows over the same IP network that the networking device are helping to create. So, again, to go back to that earlier depiction I had. All right. Telnet uses the concept of a Telnet client, the terminal application, and the Telnet server, that the switch in case. A Telnet client, the device that sits in front of the user, accepts keyport input and sends those commands on the Telnet server. The Telnet server accepts the text, interprets the text as a command, and replies back. So the same thing that using PuTTY to connect up straight through to the cable console is using that text as commands. Telnet is doing the same thing. All right. Let me rephrase that. So again, we'll have our switch. All right, we have our PC. We're hooked up to the console. We're hooked up to the console. We're sending text via the console wire. All right, so that text is flowing through that wire. All right, and it's sending it back into that switch, and that switch is taking it as commands, and it's processing that text as commands. Okay, so it's taking that text and it's processing it as commands. Okay, but that text is going through that console cable, but a console cable is not relying on IP. Okay, it is just a straight console cable. All right. Now to get to where Telnet. There's our switch. All right. There's our PC again. All right. And again, I'm going to draw a wire now, but this wire is Ethernet. Okay. Whatever. It's Ethernet. All right. I won't even, you know what? I'm going to remove it. That way I don't confuse you. How's that? Let me remove that wire. All right. And I'll put him, PC. All right, switch, and I'm going to put another switch. This is just representing, because I don't want to, because this will help me actually better explain it. So you got your switch over here, and they're all, say for instance, we're all on our one happy LAN, which again, what is a LAN, everybody? Local area network. We're all using, it's using IP 10.0.1, whatever. All right, .1.1, and PC is using 10.0. Whatever. All right. All right, Telnet. Again, what it's doing, it's relying on IP. So when you are sitting at your PC over here and you're typing away text, all right, it's sending that text via IP through the wire. All right, so it's sending all this text as unencrypted text via IP through that wire to that switch. And that switch is doing exactly what the console is doing. It's just doing what it's doing. It's taking that text, all right, and it's saying, okay, here are some commands. I'm going to do whatever, this text is going to tell me to do and whatever. And then it's going to be relaying all that information as text via IP back through the network. All right, back to the PC. Cool. Now, if Bob, the bad hacker, all right, is hooked up to this switch over here, all right, Bob, the bad actor, is hooked up to this switch over here, and he's using something simply as Wireshark. All right, and he's just analyzing the data flowing through IP, and all of a sudden he starts seeing clear text start coming through. All right, from this PC to this switch. You know, you log in with your super secret password. All right, super secret password. All right, Bob the bad actor. You know, he's gonna see your super secret password. He's gonna see all the commands. All right, you're putting into that network. That network through the wire. All right, he's seeing all of that come through as clear text now. Okay? All right, because Telnet does not encrypt anything. Nothing. It's all clear text. All right? It's clear text because that's what it was based to do. It was a way for network, you know, engineers back in the day to be able to configure these devices. It just worked. And it still works. All right? Well. Hey, guys, make sure you're not getting too big of slices. How big is same line? Let me see. Okay. As long as it's not too big. Crazy pants. Okay, not too bad. That's fine. Alright. Just wanted to make sure the kids weren't grabbing slices of slices of cake that big. It's the last thing I need the little monkeys to be up all night again. Alright. So, I hope that kind of explains Telnet for you guys, okay? Alright. Using Telnet in a lab today makes sense, but Telnet poses a significant security risks in production. Telnet sends all data, including username and passwords, logging into switches as clear text. SSH gives us a better option. Think as SSH as a more secure Telnet cousin. Outwardly, you will open the terminal emulator, connect to the switch's IP, and the switch's CLI. No matter whether you're using Telnet or SSH, the difference exists behind the scenes. SSH encrypts the content of all messages. Okay, encrypts the content of all messages. All right, including the passwords, avoiding the possibility of someone capturing packets in the network and stealing the password of your network devices. Okay, SSH. All right. All right. Users and enable privilege mode. All three CLI access methods cover so far console, Telnet, SSH. Console, Telnet. All right. So remember, console is the console wire hooked up to the PC or admin device directly. So we're directly connected via the console. Okay, that's console. All right, Telnet. All right, and SSH via. I'm gonna draw the little diagram with the switch again. The other switch. So here's our PC, here's our switch, and then this is main switch over here. Again, this is connecting via IP, all right, through the network, all right? All right, so that's the difference between console and then SSH and Telnet. Okay, guys? Direct connection, and then via the network, via IP, okay? All right, all right. Place the user in an area called the user exec mode. User exec mode, sometimes also called as user mode, allows the user to look around but not break anything. Okay, so user mode allows the user to look around but not to break anything. Cool. All right. The exec mode part of the name refers to the fact that in this mode, when you enter a command, the switch executes the command and then displays a message that describes that command's results. All right, it displays a message that describes the command's results. All right. Note, if you have not used the CLI before, you might want to experiment with the CLI from a Simulite product, Cisco Packet Tracer. All right, review a video about command line interface. You can find these, online and everywhere else. Okay, you guys are gonna see that today with when I'm gonna be using Cisco Modeling Lab here. Okay, you guys have seen. If you guys have followed this stream before, you guys have seen me use Cisco Modeling Lab. All right, and you're gonna see me use the command line interface. Okay. All right. Keep it moving. Let's keep it moving. All right. Cisco iOS supports a more powerful exec mode called enable mode. Okay, remember. So now we're getting into the weeds here. We're gonna start drawing some stages. All right. So we have user. We're gonna draw like so we have user. All right, users first. Okay. Then we have enable. All right. Sure. Spelling's atrocious. It's always been atrocious. I can't help it, guys. Wasn't born a great speller. All right, as the user, enable. All right, also known as privilege mode, okay, or privilege exec mode. Enable mode gets its name from the enable command, which moves the user from the mode to enable mode, from user mode to enable mode, okay, as shown in Figure 4.6. The other name to this mode, this privilege mode, refers to the fact that it's a more, you can do more powerful commands in this mode. That's all it's referring to, guys. It's a step. Think about this as increasing levels of power. Okay, so as there's going to be one more mode. Well, there's a couple more modes, but one more mode in particular. You're moving up the ladder of power, where you go from just seeing what's going on to talking about what's going on to then configuring what's going on. Okay, and obviously as you go, you can start, rendering commands that can start breaking things, obviously, and start messing things up. All right, and that's why it's taking like this baby step approach to how it's explaining these steps. Okay, all right. All right. For example, you can use the reload command, which tells the switch to pretty much reboot itself. All right, that's in enable mode. So you can't say do the reload command in user mode. It won't work. All right, it won't even recognize that command as on in that actual mode. It won't even recognize it. Okay, but when you get to enable mode, you put in reload. All right, it'll tab complete itself, reload, press enter, then your switch will shut down and it'll go through its whole reboot process. Depending on the switch, it could take a couple minutes to 20 minutes to a half hour depending on the switch. So again, you're gradually taking a step to more powerful commands. Okay. All right. So it's got a nice little graphic here. So if the command prompt, so here we go, showing you some little symbols here. If the command prompt lists the host name followed by a what's that? Is that less than? Is that the less than sign? Less than, greater than? Yeah, that's the less than sign. So say this is my switch name. All right, Mr. Switch, and I'll draw a switch down here. All right, so I'll say I got my two switch names. If say I got the little is that the mom? Is that greater than or less than? That always messes with my mind. So let me regress. Okay, so this right here, this is telling you are in user mode. All right, when you see this greater, less than or greater than sign. I'm pretty sure it's the less than sign. Or no, it's the greater than because it's, no. That's what it is. It's the greater than sign. Think I'm in user mode, okay? But as it's saying right there, if you see the hash sign, or the pound sign. Yeah, the hash. Yeah, the hash, the pound, hash, pound, hash. Cool. When you see the hash sign there, all right, that's telling you you're in enable mode. All right, enable mode. All right, so there you go. So the switch it's using some identifying symbols to kind of give you some context sensitive help, so you know where you're at in these things. Okay. All right. So there we go. Let's continue on here. This is giving actually a really nice picture here of where you're kind of at. All right, inside of this switch here. Okay. All right. Example 4.1 demonstrates the difference between user enable mode. The example shows the output that you could see in the terminal emulator window. For instance, when connecting from console, in this case, the user sits at the user prompt, cert skills, whatever, and then tries the reload command. The command tells the switch to pretty much reboot the Cisco iOS. So the Cisco iOS, this is a powerful command, and is only used from the enable mode. iOS rejects the reload command when it's used in user mode. Again, we were just going over. Then the user moves to enable mode, also called privilege mode, using the enable exec command. So enable, that's all it's doing, enable command. All right. At this point, the iOS accepts the reload command and then reboots the switch. So now, all right, when it starts showing, we're gonna start seeing more and more of these code images here, guys. This is actual this is actually popped out of the actual command line interface. So this is what you guys are going to be seeing when we're going to be using the command line interface. Okay, so he or she logged into the switch. The cert skills, don't get hung up on this. This is just the host name of that switch. You can name your switch whatever you want to call it. You want to call it Obi-Wan Kenobi, Tadawan, Tatooine, whatever, Darth Maul, whatever you want to call it. You can call it whatever you want. All right, so don't get hung up on the name. This don't matter. All right, what matters is this greater than sign. That's telling you you're in user mode. All right, so when he or she tried to do the reload command, it said, no, you don't have that privilege. All right, so then it said, okay, you don't want to let me do it? I'm going to go into enable mode. So he or she put the enable command mode in. It prompts for another password. All right, now when you see this and then you don't see nothing afterwards, this is on command line interfaces like Linux, Cisco, Cisco iOS, and some other operating systems, more secure operating systems. It shows nothing. So don't get scared if it prompts you for a password. You start typing, you don't see anything at all. You don't see not even like hashed out symbols or anything like that. It shows nothing. So don't be aware, don't be scared or nothing like that. All right, just put in your password. It's for your protection. So, it's so if somebody's looking over your shoulder, they can't even see how many characters you're putting in. Okay, that's all it's doing. Okay, all right. So again, so they put in their password. From there, their password worked, and then they were able to move into enable mode. And that's what you're seeing there by that little hash sign there. So then they prompt to do the reload command again, and then obviously in enable mode, you can do the reload command in enable mode. So and then it prompts you for the when it says confirm, just a simple Y or N that tells it yes or no. That's how to initiate more exec commands from there. Okay. All right. The command that can be used in either user exec mode or enable mode are called the exec commands. Cool. All right. Password security for CLI access from the console. A Cisco switch with default settings remains relatively secure when locked inside of a wiring closet. Cool, because by default, the switch allows console access only. By default, the console requires no password at all, and no password to reach enable mode. For users that happen to connect from the console, the reason is that they have to access the physical console port of the switch. You already have a pretty much complete control over the switch. So the logic behind that. All right. So again, if you didn't catch what I'm saying, so by default, Cisco catalyst switches in console mode, you don't, by default, doesn't require a password. That is because the logic is saying, okay, if somebody can actually physically connect a cable to this Cisco catalyst switch, then they've already got control over the switch. You know, what doesn't say they just don't rip the switch out of the wiring closet and take it down the street. All right, so that's just kind of the thinking behind. That's the logic behind that default. All right. Yeah, you can. There you go. So you can unplug it, take it for a walk. Sure. All right. However, many people go ahead and set up a simple password protection for console users. So you can set up a simple password for the console. Okay. Can be configured at 2 points in the login process from the console where the user connects from the console and when any user moves to enable mode. Using the enable exec command, you may notice that back in example 401, the user saw a password prompt at both points. Okay, so remember it prompted when the user logged in, and it also prompted when the user was trying to get into enable mode. Okay, so it was prompt for two. It was being prompted for two actual hold on. It was being prompted for two actual commands. Two passwords, okay? Oh. Hold on, guys. 1 second. Actually, let me grab a drink real quick, guys, because I'm getting a little getting just a little thirsty. Just give me 1 second, guys, okay? Be right back. All right, I'm back, everybody. Just had to grab a quick drink. Thank you. Thank you for being patient, guys. Just had to grab a quick drink. I was getting thirsty. Woo! Had to wet my whistle. All right. All right. Let's continue on. All right. As we were just saying, so you can set up a simple password for the console use. Okay? Cool. All right. All right. Example 4.2 shows the additional configuration commands that were configured prior to collecting the output. In example 4.1, the output shows the export show running config. So the show running config, that's an actual command. So this is a very, very useful, super useful command, guys. This command right here, this will help you a lot. This will help you, when you're stumped. You'll see me. I run this command all the time, guys, all the time. Just because it shows you what you're doing. What have I entered so far into this switch or router or whatever am I doing? So you can go back and you can troubleshoot. Troubleshooting is super important, guys. And troubleshooting actually helps you learn. By making mistakes and going back and troubleshooting, using the show commands. And there's a whole array of show commands. All right, but the show running command, that's for me, that's my go-to. That's my go-to boy right there. I use that whenever I get in trouble. You'll see me use it all the time. All right, and it'll show you. You'll by using the space bar, you can continue to page after page and page. It'll show you all the way to the very last page. All right, or you can use tab or Q, and that'll stop the pages from there. All right, but this is showing just a quick splurt of So here you're here's the host name and then the hash sign. Okay, remember, it's in enable mode. By seeing that hash, you're in enable mode. Okay, and then you're gonna run the show running config. Okay, and then it's gonna think about it. It's gonna say building configuration, and then it's gonna start outputting the configuration details for your Cisco Catalyst switch. Okay, all right. Here we go. Yep. All right. The enable secret love. Well, the enable secret. Don't worry about the love. Love has nothing to do with it, baby. All right. The enable secret. What that command is going to do. That's to enable, and that gets into global configuration mode here. You're going to be able to create an encrypted password. Okay. All right, and that's what it's showing. Is it showing it on this one? Oh, so it's not. So it's just saying enable secret love. All right. Once we get down to the point, you're going to see where you're going to create the enable secret password. That will be an encrypted password that when you run the show run command, you won't be able to see it as clear text. But this is just demonstrating that you can still see it as clear text. Okay. I got a hole in my lip. All right. All right, the final three configure the first line console 0. So this is just getting into, from line console 0 is the command that identifies the console. Basically meaning the next command applies to the console only. The login command tells the iOS to perform a simple password checking at the console. Remember, by default, the switch does not ask for a password for console users. Finally, password faith command defines the password. It's just going through the motions of. It's just talking about this, and I don't want you guys to get hung up on that right now. All right. CLL help features. If you print the if you printed the Cisco iOS command reference document, you would end up with a stack of pages several feet long. You would. And no one should expect to memorize all the commands. Now, on that note, though, I'm going to suggest another, and again, guys, this goes back to me and my love for actual hard copy books, all right? So here's another great book, guys. It is the CCNA, all right, portable, the CCNA 200-301 Portable Command Cert Guide, actual book. And what this book goes through, it goes through every configuration inside of the Cisco 200-301 exam book, okay? It takes every configuration, not everything in the book. It takes every configuration that this book's are going to talk about, and it's dumped that all into a very, very portable, and trust me, I take this along wherever I go, a portable book, so you can walk through setting up, setting up SSH, setting up Telnet, DHCP, NAT, PAT, OSPF, on and 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 on. All right, Cisco. I'm telling you guys, Cisco. This is why I love Cisco and Cisco everything. I love Cisco. Okay, just because all of their what they do is everything that they have, they want people to learn this stuff. They're not trying to hide anything. They want people to learn this stuff. So they make products around people learning this stuff.
Mommy said she loves you.
Oh, mommy loves me. That's amazing. I love that, mommy. I love
She has to, it's on her break right now. She has to go back.
Okay, that's cool.
And she's almost going to be home in 12, so she gets an hour long.
Oh, she has to stay an hour longer tonight? Alright, so she won't be getting home too late. Boy, the wife's working late tonight. Alright, thank you, Max. Alright. Let's continue on. Alright. So again, let's continue on. The question mark. Question mark is a very, very useful, again, another super useful command. It gives you context sensitive help. Alright? Wherever you're at, within any mode, you punch in whatever command, and then you get stumped on, okay, what was that next line in my command? Can't think about it, just space question mark. Okay, it's going to start feeding you some text, some information of all the commands that are coming up. All right, what commands can you put in next? All right, so just for instance, all right, we're here we are. We're in enable mode, okay? And we got show. We put show in, all right? And we want to see all the commands that I can do. Show what? Show whatever. All right? So I'm just gonna do simple show question mark. What's gonna start happening next is the Cisco catalyst switch, the router, whatnot. It's gonna start just dumping out anything. It's gonna start running config, whatever, IP route, so on, so forth, and forever. It's just gonna start dumping out possible. Now these are possible commands that you can run next, okay? It's not gonna give you commands that are just not gonna work. It's gonna give you possible commands that will work, that will show you more information, and you can continue. You put in the running or whatever IP route, and then you do question mark again, and if there's any more commands that can go along with those commands, it's going to give you another list of commands until you got a laundry list of a syntax that then you can press enter finally. And then you're going to get your detailed, obviously the more syntax you're dumping in, the more detailed of the information you're going to get. So the command, the question mark, another powerful help command, okay? Super powerful, guys. I use it all the time. And so should you. All right? Let's continue on here. It's just going to tell you some keyboard shortcuts. So here's just some keyboard shortcuts. I'm not too, just because I'm always going back and forth from this thing to the big keyboard. For me doing, I'm not the greatest keyboarder in the world. Don't let me get you twisted. But if you guys are, here are some keyboard shortcuts for you guys. Read them and weep. Use them. I wish I could have the memory to remember that. I use the backspace though. All the time. Alright. Alright, the debug and show commands. By far, the most popular Cisco iOS command is the show command. Like I said earlier, the show command has a large variety of options, alright? In which those options can find the status of most of every feature of a Cisco iOS. Initially, the show command lists the currently known facts about the switch operating status that only works with the switch. That only work with switch does in reaction to the show command in this field to the current status and list information in a message sent to the user. Cool. There you go. So, woo! I highlighted all that. So, show MAC address table dynamic. All right. Boom. Is show MAC address table dynamic. All right. Again, the show command is very, very powerful, guys. All right. The debug command. I don't really use the debug command too often. The debug command also tells users details about the operating switch. However, while show command lists status information at one instance of a time, more like a photograph, the debug command acts more like a live video camera. Once you issue the debug command, the iOS remembers issuing the message like any switch. Yeah. All right. Configuring Cisco iOS software. You will want to configure every switch in the in an enterprise network, even though the switch will forward traffic even with default configuration. So pretty much, yeah, you can just take a brand new switch, dump it into your local area LAN or whatnot, start hooking up to your ports, and wham bam thank you swam, your switch is going to start doing its thing. All right, that's as default and as basic as you can get it. All right, but once you get into VLANs and RSTP and STP, and access list, and controlling your traffic, security, then you need to get into your switch. You need to start configuring it. You need to start working with the command line interface, and that's what this is really touching on, guys. Okay, all right. Now we're gonna jump into configuration mode. So this whole entire time, guys, we've been just talking about user mode and enable mode. All right, we haven't even gone into configuration mode yet. All right, configuration mode. That's when you can start configuring things. Obviously, it's called configuration mode. But that's when you start, setting up the configurations and programming it, or breaking it. If you're like me, sometimes you mess everything up and you just gotta wipe the whole thing and start all over again. All right. So you have some configuration submodes in context configuration. Configuration mode itself contains multiple modes to help organize the configuration. iOS groups some kind of configuration commands together. To do that, when using configuration mode, you move from the initial global configuration mode into sub command mode. Context setting commands moving you from one configuration subcommode or context or to another. These context setting commands tell the switch the topic about which you will enter the next few configuration commands. All right. More importantly, the context tells the switch the topic you care about right now. So when you use the question mark to get help, the switch gives you help about the topic only. So that's just, again, it's just going back to, now, this is going to be you're going to see switch config. All right. You're going to see switch config mode. And then, say you want to move into interface. And you don't remember the specific actual interface the specific name of the interface, you know, obviously then you're gonna drop the question mark, and it's gonna run through, you know, fast Ethernet, gigabit Ethernet, or by, you know, in another, you know, say you're in switch configuration mode again. All right, and you want to move to, you know, you know, line console, you know, your line console. All right, and you can't remember what the specific number for the line console, you know, dump that in there. It's going to give you some context sensitive help, guys. Okay. All right. The best way to learn about configuration submode is to use them. But first, take a look at these upcoming examples. For instance, interface commands is one of the most commonly used context-sensitive setting configuration command. For example, the CLI user could enter the interface configuration mode by entering interface fast Ethernet 0-1 configuration command. Asking for help in interface configuration mode displays only the commands that are useful when configuring Ethernet. Yes. So once you then get into interface configuration mode, all right, once you found your configuration mode and then you press, you enter that question mark again, then it's only going to give you what this is stating. It's only going to give you context sensitive help. But that mode, okay? But that mode, it's not just going to keep giving you every single command that the switch can do. All right? The switch is you got to think it's almost set up like there's like levels or trees. It's almost, so I guess again, that's if you've used Linux operating systems or whatnot, but it's still different than a Linux operating. It's totally different than a Linux operating system. How can I best explain this, guys, so it kind of makes sense? We'll take a stick, okay? And say I'm over here, all right, and I got a couple of levels, all right, whatever, all right, and I'm over here, all right, and I put the question mark in, all right, I'm not gonna get any of this or any of this, all right, and I'm not gonna get any of those commands, all right, I'm just gonna get the commands that relate to me where I'm at. All right. Same thing if I'm over here. All right. I'm over here on the very base level. All right. Again, I'm not going to get any of the commands from up in here. I'm not going to get those commands. It's not going to give me that. It's just going to give me the commands that refer to me when I'm down in here. Okay, that's what this section is talking about, guys. And I hope you understand by me going over it in this type of way to kind of give you some, visualization into how this is working out and how the iOS operating system works. Okay, it's different. It's different than Linux. It's different than Windows. Okay, it's different. All right. All right. Yep. So that's just pretty much, again, hopefully with my example on how it's only going to give you context sensitive help to where you're at. Okay. Yeah. Here's some key topics. This is just demonstrating. It's just going through the different configuration modes. Okay, that's what this is doing. It's just showing you the different titles that you're going to see, the different titles you're going to see as you're going through the configuration sub modes. Okay, so when I'm over here and on this level, okay, I'm going to see host name config, host name. All right, config. All right. When I go to the line mode, I'm gonna see host name. All right, config. All right, config line. All right. with parentheses, those parentheses, right? All right, then I'm gonna go to the, say I'm in interface mode. I'm gonna see host name. All right, interface. All right, config if. There we go, config if. All right, config if. All right, VLAN. All right, again, here we go. Host name. VLAN. All right. Now again, to go back to what I was saying, I say I'm in host name VLAN sub configuration mode. Okay. I hit the question mark. Again, I'm only gonna get that context sensitive help for the commands that are relate to the sub mode VLAN sub mode. Okay. I'm not gonna get any of those commands for those other modes. Now you're gonna have your commands that there are some crossover commands. There are some. I'm not gonna say there isn't, but you're not gonna have every command in this whole entire tree or whatever I don't want to call it a tree, because if you've used Linux before, Linux, you think of Linux as a tree. All right, so I'm not gonna say tree, but you're not gonna get you're not gonna get that. So again, you're just gonna get the context sensitive help for the for the configuration sub mode you're in. All right. All right. All right. There's almost a nearly exact representation of what I was just drawing there. All right. It's almost like I've seen this before in my mind. All right. All right. No. You can also move directly from one configuration sub mode to another. So you can. So say if I was in interface, gigabit 0-0, I can go from interface gigabit 0-0 to interface, gigabit 0-1 or fast Ethernet 1. You can move in between those sub commands, all right? As long as you knew the exact command on how to spell it, okay? Because as you get into the sub command levels, you're not going to get tab assist. When I mean tab assist is a lot of commands you can press. You don't even have to completely spell it all out. You just have to start it, tab, and then it'll tab complete, all right? But once you get into the sub command levels, and even more than that, you just have to know the abbreviated spelling or the exact spelling to wherever you want to go within those modes, and you can go between those modes. You can jump from all the way up here to all the way down there. You just have to know the exact spelling, okay? So that's it. All right. So storing switch configuration files. When you configure a switch, it needs to when you configure the switch, it needs to use the configuration. Obviously, it also needs to be able to retain the configuration in case the switch loses power. Cisco switches contain random access memory. Okay, RAM, random access memory. Let's write that down. All right. Let's write that down. RAM. Ramrod. Team Ramrod. Random. Access. Memory. Alright. RAM. Team Ramrod. Alright. RAM. Random access memory. RAM. Random access memory. Boom. It's drilled into our heads. Alright. Alright. RAM. Sometimes called DRAM for dynamic random access. RAM is used by the switch just as it's been used by your computer for storage. The running active configuration is stored there, okay? Let me repeat that whole thing again. So RAM, sometimes called DRAM for a dynamic RAM, random access memory. RAM is used by the switch just as it is used for your computer for working storage. RAM is used for working storage, okay? Once the power goes off, that's it. Everything in that storage, gone. All right. Flash memory, either a chip inside the switch or a removable memory card. Flash memory stores fully functional Cisco iOS images and is the default location where the switch gets its Cisco iOS at boot time. Flash memory also can be used to store other files, including backup copies of configuration files. ROM, okay? Don't get ramrod and ROM confused, all right? ROM, read-only memory, okay? Stores a bootstrap or boot helper program that is loaded when the switch is first powers on. The bootstrap program then finds the full Cisco image and manages the process of loading the Cisco iOS into RAM. All right, and which points Cisco's iOS takes over the operating system. Okay, so ROM boots up the switch. All right, I'm just trying to put this into simplest forms. All right, it boots up the switch. Okay, ROM takes the ROM takes the ISO image from flash memory, okay, from the memory storage, okay, and it loads that into Team Ramrod, all right, and then Team Ramrod takes away and then starts, running your switch here, okay. So ROM, read-only memory, stores the bootstrap program, okay. Flash, that's where the ISO is stored. RAM, that's where that's the working storage, okay? All right. NVRAM, non-volatile RAM, stores the initial or startup configuration that is used when the switch is powered on. All right? So, when you are in your switch and you're doing all your configurations, okay? All right? It's going to be then saved over to NVRAM, okay? So, when Team Ramrod boots up, all right, it's going to capture the ISO image, all right? Then, obviously, now that we have a configuration booted in there, now it's going to talk to non-volatile RAM. It's going to get the initial startup configuration running. But then all the way it goes back to RAM, and then RAM's still going to run the now running active configuration file. Okay? All right? That's kind of how it works. All right? All right. So this kind of like summarizes it right here for us. Okay? RAM, working memory and running configuration. Flash, that's where the actual software, the iOS software, is being saved. Okay. ROM, that's the bootstrap program. That's the program that says, "Here we go, we got it." All right. And then non-volatile RAM and VRAM, that's the starting configuration. So all that is that's just a simple text file. So that's just a simple text file that holds. When you do the show run command, that's just a simple text file. That's what's just being after you copy running startup, running config startup config. That text file that you just saved, all right, is being saved to NVRAM as a text file. Okay, and then that's just being used when ROM gets the image from Flash, and then Flash, and then NVRAM says this is going to be the startup configuration for it. All right. But then once that's initialized, all right, it's on RAM. RAM's holding it after that. All right. Anything you do after that is being saved to RAM. All right. So that's why you got to then save it right back to NVRAM when you make any changes. Or NVRAM, when say you lost power, NVRAM's just going to have that, it's going to have that saved text file from the very, 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 very last time when you did the running copy, the copy running config, startup config. It's going to have that just text file sitting back in its NVRAM. All right. So that's why you have to run the copy running config all over again. So RAM can then put a new text file in NVRAM. All right. Hope that makes sense. All right. So there it is. Yeah. Cool. Yeah. So if I were to do, I boot up my switch, whatever, and I start going ham Larry on my configuration, and I run, show running config. I'm gonna get this nice cool text file of everything I just did. All right. I clear that up. I run, show startup config. I'm gonna get a whole different sack of potatoes in that startup config file, because you haven't saved it yet. You haven't saved what you've done in so far, what you've done in RAM. You haven't saved that to NVRAM. So and then, okay, so I do my copy run start, my copy run config startup config. I run that command. All right. Then I can run startup. I can run show startup config and show running config, and they'll both be the same. All right. But then 10, 15 minutes later, I start going again. I start messing around with my configurations. Now they're completely different all over again. All right. You do these commands again, you're going to get, again, 2 different text files. All right. You've got to continue to best practice is to, as you're going along, just do, every once in a while. That's obviously, again, I'm going to show you something, but I'm going to quickly erase it so you don't see it. All right. You're gonna see me do this command every once in a while. All right. You're gonna see me do the do WR. Don't look. I'm gonna erase it just as fast as I put it up there. All right. So you didn't see it. All right. But you're gonna see me do that every once in a while as I'm going along here. That way I'm copying my running file to my startup file, guys. All right. Just in case something happened, I don't want to do it all over again. All right. Alright, so it's just talking about that again. It's just talking about how to erase your configuration now and whatnot. Alright. Chapter and review. Alright. So we've talked 3 methods of accessing the switch command line interface. Cable and options, Cisco switch default console port settings, navigating between enabled, user enabled and global configuration, a list of configuration prompts, configuration mode, context setting commands, the name and purpose of the in the switch, the names and purpose of the 2 configuration files in a switch or a router. All right. Some key terms that you should know: command line interface, CLI, telnet, secure shell, SSH, enable mode, user mode, configuration mode, startup config, running config. All right. Now the book's going to start giving us some command references. All right. So we have line console 0, login, password, interface, host name, exit, and control Z, no debug all, undebug all, reload, copy, config, startup config, copy startup, copy running config, startup config, copy startup config, running config, show running config, write erase startup config, erase on VRAM, quite. Show startup config, enable, disable, configure term. Alrighty then. Woo! Sweated some bullets. Alright. Let's dive into some lab time. It is lab time, boys and girls. It is lab time, boys and girls. Man, I got such a beautiful voice. I can't even control it, guys. I can't even control it. It's unbelievable. It's unbelievable. All right. I'm going to go to my other. I'm going to go to my other scene real quick. Wappy this out. Off. What's up? Alright. 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 Right here. I'm sitting down. Nice and comfortable. Alright. Let's come over here to CML. Alright, what are we gonna do? We'll stack you up. Alright. Make you smile. Grab. Switch. Grab a switch. That's it. We just need to power on our switch real quick. That's it. That is it. And then we'll just go through just some very yeah, we're just gonna cover, you know, moving through exactly what this chapter talked about, guys. We're not gonna get too far into anything. All right. I just want to walk through some of the steps that this chapter covered. All right. Yeah, that's it. Anybody got any questions out there? About anything at all? It's kind of like the time. Kind of the time to. We'll do some Q&A if anybody has anything for me. Okay, guys, try to keep. If you guys do have any questions for me, try to keep it within the realm of chapter 4. Okay. And I'd be more than happy to answer your questions. Yeah, this has been. I think this was a really good chapter. Again, this is we're gonna start getting and diving into deeper. It's gonna take us a lot. Chapter 5, 6, and 7 will really be heavily revolved around just layer 2 switches. Okay, layer 2 switches. All right. And there's a lot that goes. Switching itself, switching logic. Once we get past a lot of the switching logic and stuff, that's gonna really set us up. It's gonna set us up for success as we get into. Let me just check my YouTube chat. I haven't checked that since I've actually started. It's bad on me. So hold on. Let me just make sure I got no chat going on YouTube. And I apologize to my YouTubers out there if you are chatting. Okay. I haven't seen any. I don't see anybody in YouTube chat right now. I gotta get another bigger. The only other monitor I got is a 7-inch monitor, which when I dump my streaming software onto it, that's all I can fit on it. The screen doesn't let me fit anything else. So yeah. So if I'll for the next couple of minutes, my YouTube chat, my YouTubers, I'll monitor back and forth to make sure if you guys have any questions for me, that I will do my best to get to you guys. So yeah. All right. It doesn't. This switch shouldn't take too long for the switch to boot up. There it goes. All right. Beautiful. All right. All right. So we just pressed the enter button. Our switch says just turned on. All right. I just pressed the enter button. So we are officially in user mode. Okay. We have the little monster sign, the little greater than, and I believe it's the greater than sign. If I'm not, somebody correct me. So you're seeing insert username here. That's just the default username, the default host name that it's giving us. Okay, will give us some context sensitive help. Remember the question mark. So all I did was I ran the question mark. Okay, and from there I got a list of commands that I can run. And it even says right here, exec mode. Okay, so exec commands. So in here, I can access enable, all right, access profile, clear, connect, crypto, yada, 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 enable. So that'd be the mode. So turn on privilege commands. So that'd be the mode we move into next. I can exit, I can ask for help, I can lock, I can log in. I'm gonna press the space bar. Remember, the space bar will page down some more commands, okay? Resume. Here's some show. We can do some showing. We can SSH if we had an SSH client to log into. We can telnet into another client if we wanted to too. We can ask where. All right. We can do some trace routes and whatnot in this mode. Okay. We can also ping. You know, we can send another echo message. That's if we had IP set up on this switch and whatnot, because you got to, well, the switch image that I'm using is the Cisco iOS. It's the, let me just, so I'm not tripping over myself. It is the Switch iOS VL2, which is an all right. It is a layer 3. It's a layer 3 virtualized layer 3 Cisco. So that's what that I'm using right now. All right. So remember, from here we're gonna do enable. Okay, we're gonna go into enable mode. All right. I'm gonna press enter, and then again we're gonna get that little hash little sign there. That's telling us we're now in enable mode. I'm gonna press the question mark again, and it's gonna show us what commands we can do in this mode. All right. And as you can tell, we've already got a little bit more commands. All right. So this is, let me see. We'll do 1 scroll, 2, 3, about 3 scrolls. Okay. So let's start here. 1, 2, 3, 4, 5-ish, 6. I'm gonna say 7, 8, about 8 pages. So we went from about 4 pages to about 8 pages worth of the commands. All right, that we can now run in enable mode. All right. Now in enable mode, we have some more power. All right, we looked at, we can reload. So I don't want to reload this again, but what I'll do is let me exit. Let me exit now, and we'll start back from the beginning again. All right, so we started back from the beginning again, and say I want to run the reload command. Oh. Well, now it's thinking I want to look for reload.com. It's looking for the domain name server reload. Well, all right. So there is a function. Again, this is because this is a layer 3 image, which it has the power to do some IP routing in it. You know, I can set this thing up to be a legit C router. I can set up DHCP on this thing, and you know, and a host of other commands that you can normally do on a router. I can, you know, set it up on this layer 3 switch, which is neato. But as you can tell, it doesn't have the reload command in it. Go to enable mode. All right. Now I'm just gonna show you that it has the. So I I'm just using the tab. The O. Alright. So I tab completed it, and it's showing that it has the reload command in it. Now I don't want to reload it because it's probably going to take a couple minutes to actually start the whole thing up again, and I don't want to go through that process. But we'll do the question. I'll show you that the command exists. All right. You stinker. There you go. So halt to perform a cold reset. Let's just go back one. No. How about I gotta turn that off. Yes. Yeah, looking. So inside of your once you do start labbing things up, you can turn that off. So that is once you get to global configuration mode, which we'll move into next. We can turn that off. It's IP. We'll do the IP space domain dash name lookup command, and that will turn that actual function off. So because that what happens is if you once you start punching in commands and going to town, if you by accidentally misspell something, you press enter, it'll do the same thing. It'll start looking, it'll start looking for it.com, whatever. And it, obviously it's not going to exist. What I wanted to do was exit, go back to enable mode, do the question mark, and show that the actual reload command does not exist. So there it is. So here's all of our R's, and as you can see, the actual reload command does not exist in that mode. Cool. We can move on. All right. Enable mode. All right. Oh, I showed you some more shorthand. I shouldn't be showing you shorthand. So yeah, there's some shorthand for you. So from here, what we will do is we'll do our first show command. Okay. We'll do show running config. Okay. Now, what it's going to show us is the current running configuration that the switch has. Now, this was a brand new image, and we haven't done any configuration at all. So, as you can tell, it's not showing anything, not showing any passwords, not showing anything for all. All of our interfaces are just standing there. Now, what you're seeing here, and don't let this again start messing with you. All right, if it has already, and if it hasn't, then good. But this image now, this is just to this image. You may not see this if you're say using Cisco Packet Tracer or using even your home. Even if you say you have real gear at home, these interfaces may have different names due to different speeds on their ports, different numbers due to different numbering. So don't say, hey Joe, why does your interfaces say something different? That's because this virtual image here, it's only by default. I can add more interfaces to this if I want. By default though, it only has 4 interfaces on there. All right, and they're all acting as gigabit interfaces. Okay, all right. Now this is a virtual image. So, again, don't let that confuse you or anything like that. And if you have any questions, just ask me, guys. All right. So let's press spacebar again. Spacebar again. And boom. So that's the end of our actual show configuration. So from start, show configuration. All right. All the way down, spanning tree. Yep, really nothing at all. No IP forwarding. The IP server is not set up. Yep. Nothing on the line console. So this right here, this is representing that's the console. Okay. All right. And then over here on the VT wide lines, that's where you can set up SSH and Telnet and whatnot, those services as well. Okay, we won't be doing that here in this class today. All right, on this stream today. All right. So that is the initial running. So let's just do this. I'm just gonna do this just for sake of doing it. I'm gonna run the start configuration just to show you it is the exact same thing currently. Okay, it's gonna be the exact same thing as what we just ran as our running configuration. So currently, the running configuration and the startup configuration is the exact same thing. All right. Funny that says no CDP enabled. Whatever. Same thing. So it's showing absolutely nothing. It's showing no configuration at all. Okay. So let's go into configuration mode. All right. Configure. Terminal. All right. Configure terminal. That's going to get us into global configuration. Okay. Now I am just going to go into global configuration mode, and I'm just going to do a couple quick settings just for the purposes of then going back and showing the show command of the running configuration and then the show command of the startup configuration, just to show you that now there is a difference between what RAM has as its current file, running file, and then what NVRAM has as its startup file. Okay. All right. So again, here I am. I am in config. Remember. So here's that little hash sign. Now I've moved into config. All right. Global configuration mode. All right. It gives me a nice new sign here. All right. I'm going to say host name. All right, host name, and we're just going to call you Switch. All right, I'll call Mr. Switch a Switch. Okay, let's set a password. All right, let's set a password. Let's say love. Love. I love love. Just messing around, guys. Really, not doing much. Okay, so I moved back out. Not gonna save it. Move all the way back out. I'm gonna go end. Cool. So we've gone back to enable mode. Let's exit. All right. So now let's do a show run. Okay. host name switch. Cool. Now I got a couple of VLANs with some IP addresses here. Cool. All right. All right. Host name. Insert host name here. Whoa, that's a different one. So, if you remember when we first booted up the switch, the host name was insert host name. Okay? But over here on the running config, it's showing our host name is switch. Alright? So, here we go. Let's go down. I got no VLANs. Where'd my VLANs go? No! My VLANs are gone! Alright, look at that. So, we have our VLANs are gone. Our IP addresses that we just set on our VLANs are gone. But they're in our running config though, right? Yeah, they're over here. Here's our VLAN 10 and VLAN 20. Alright. And now again, that goes to show you it's two different. Alright. So the file that is now running in my RAM, it has not been saved to my NV RAM. Right? So that's that. This is a text file. Okay. All right. And then this is a whole nother text file. Two different text files. I need to now copy my running text file to my startup text file. So copy running config to startup. And yes. Now we'll run that same command over again. We'll run the startup. So the show startup config. Now let's take a look at it. Holy guacamole! Now it's saved our hostname as switch. Okay, cool. Oh, cool! It's now saved our VLAN information, what our VLAN IP addresses that we just assigned to it. Okay, so we've taken that file that was running in RAM and then saved it to our NV RAM. Pretty cool stuff, right? So that's the importance, right? Now, again, here's my little. I don't want you guys to see what I just did. Don't look at it. I'll cover it up with my mouse. There's the R, the WR, just for shorthand. All right, that saves you a lot of typing. Well, guys, let me just check YouTube one more time to make sure nobody's chatted it up in YouTube. Nobody's chatted it up in YouTube. Very cool. All right. This has been a very, 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 very good stream, and I hope you guys are really enjoying this. I'm having a lot of fun doing this, guys. So tomorrow. Let's just do a quick, let's do a quick look at tomorrow, guys. All right. Tomorrow, analyzing Ethernet LAN switching, okay? Network fundamentals, explain the role and functions of network components, L2 and L3 switches. I kind of touched on that today. There is a big difference between what an L2 switch can do and what an L3 switch can do, okay? Describe switching concepts, MAC learning and aging, frame switching, frame flooding, MAC address tables, okay? So that's going to be tomorrow, Chapter 5, analyzing Ethernet LAN switching, okay? Now, what I want to just leave you guys with, if you do guys have the time, and if you do, and again, if I urge you, if you haven't done it already, and if you're interested, I would suggest going over to the Cisco NetAcad site there and downloading your free copy, Cisco Packet Tracer, guys. It's, you know, there's, I want to say, there is a, probably about 10 to 15. It comes with about 10 to 15 labs in there. But once you get on the Cisco NetCat Academy, you can sign up for a couple of free courses, and they'll actually give you some really, really nice introduction packet tracer labs that you guys can start playing with and going through it and step by step, just so you guys can get some hands-on with going through the command line interface and whatnot. What I am working on is the labs that I create here on Cisco Modern Lab. What I am planning on doing is just remaking them over in Cisco Packet Tracer and then putting those up on my Discord server. So while you guys are joining me and whatnot, you guys can join up on my Discord server, and you guys can download those files and do what you want with them, play with them, break them a million times. I don't care. They're yours. And that way you guys can get as we're going through these study streams and whatnot, you guys can follow along. That's just an extra element that I want to be able to give you guys as you guys are joining me live on these streams and whatnot. Again, guys, from my house to yours, thank you very, very much. I love every single one of you guys. And remember, tomorrow, make sure you guys are here. 5 o'clock. 5 o'clock Eastern Standard Time, 5 o'clock p.m. Eastern Standard Time. We'll be joining back here tomorrow. All right. And again, as I always tell you, the CCNA study stream that's weekdays. Okay, that's weekdays. All right, Monday through Friday, 5 o'clock 5 o'clock p.m. Eastern Standard Time. All right. And there is some stuff I have planned on for the future. You just stay in touch with me, guys, and I'll keep in contact with everybody, and there'll be plenty of more content where this came from. So thank you very much, guys, and have a good night. Bye, everybody. Have a good night out there, guys. Thank you, guys. Let me just stop this live. All right.